Okay, this is, of course, probably the first fully remote conference most of us have attended. So I think there are going to be a little bit of a learning a little bit in terms of how we chat and communicate. But it sounds like I've got a moderator to help. So if you have any questions at any time, please feel free to raise your hand, comment, or pop over to the Marvelous and Heroic Systems channel in Slack. But I'll just jump right in. To get started, hopefully all of you have cloned this project right here. It's in the chat. And then I will just jump right into my intro. So the primary target audience for this talk is individuals who maybe have done a little bit of Clojure, maybe you're a year or two in, and you're trying to figure out, like, how do I, I've done the katas, I've done the foreclosure exercises, I understand how map, filter, and reduce work, but there's still kind of that missing link of how do I build a full stack, or at least a backend system that is stateful, that is still written in a functional manner. Because oftentimes we still kind of hold on to those ideas we've learned about how we build stateful systems. And so I really want to talk about from the get-go how you think in Clojure, starting from just thinking about data and then talking about building functions around that data since you're building bottom up. And then I want to talk about state. And so to do that, we need something that's stateful. So I have two things we're going to use. One is Datomic and we're going to use data strip. Datomic, data strip, data hike, and data log. If I use those four interchangeably for this talk, hopefully the context makes sense, but by and large, they can be used to represent the same concepts. And then we're going to talk about that, how we do data modeling with particularly data script and data hike. And then finally, I'm going to talk about how you build a backend with that. And then we're going to bring it all together and go then again just from plain old data all the way to having a complete backend application that has managed state written in a way where we've pushed all of our state to the edges and it's very functional on the inside. If you're following along, you can do it a couple of ways. Probably the best way would be to follow along in the namespaces. Everything is organized, so it's sorted, and you can just start right from the top, and you can just work your way all the way down through. Everything is, I believe, very well commented and should be working. Also, if you want, either for now or for future reference, there is a link that is found in the README that takes you to this marginalia document, and it also is sorted lexically, so you can just scroll through and read all the comments that go along with the exercises as well as the code. So hopefully it'll give you, later on if you're thinking, man, how did we do that? You can go back and get a refresher or share it with your colleagues. All right, so let's jump right in. I want to make sure that there are people out there. Somebody like raise your hand or ping me. I feel like I'm talking to nothing. Make sure we're good. Anyone in the chat? All right, I think I see, all right. I see Nick. All right, let me jump to my screen. All right, let's jump in. I've taught Clojure for several years now. I've been a Clojure advocate and champion at 2 companies now. I've grown multiple teams and I've talked to a lot of people. What I found is when you jump into Clojure, one of the first things people do is they glom onto this idea that it's functional, or maybe they glom onto the idea that it's a list, or maybe even macros, which is probably not the right thing to glom onto right from the get-go. But that's typically what people will do. And what I found is it's much easier in Clojure to get started thinking about data. We've actually had some fantastic talks just right before this one about DSLs. We had some conversations about, well, at what point does data become a DSL versus just being data? And that's I guess a topic for another day. But the cool thing with Clojure, though, is that when you start with a new project, a new problem, or if you're new to learning the language, what I highly recommend is instead of jumping into the code, jump into your domain as data. And it doesn't matter. So I work at Clearwater Analytics. It's a fintech company in Boise, Idaho. And we do Clojure, at least on my team and a few others. It's really cool. But whether you're in fintech, whether you're in biotech, whether you're in game tech, whatever it is, if you're doing Clojure, you want to start with your data. And so there are just a few key data structures, and we're going to start very baby step, but we're going to move pretty quickly. So we have in Clojure, we have our vectors, which is just the way we ordered, we manage our sequential things that are indexed. We have maps, which are your hash maps, your key value pairs. We have sets, which again are your hash sets. And then finally we have lists. And I think everyone here probably has enough experience to know lists typically are things you're not really doing much data modeling on. Most likely you're going to be using a vector instead. So when you're starting to learn Clojure, what I recommend is, again, start with the data, start with your domain. And it was even came up in the last talk that once you get that domain model right, you get that data model right, everything else becomes pretty easy. And I found that to be true. And so typically if you're having a problem, then what you should be doing is instead of like debugging or stepping through code to figure out what's going on, go back to first principles and look at your data. So today, my talk, as it says, is building a marvelous and heroic system. So we are going to be dealing with superhero data. So I'm going to be walking through that and how we might model and build a system all about keeping track of superheroes. So I think all of us think that superheroes are pretty cool. So the first challenge, and most of these, rather than take a break, what I'll probably do is explain it and then maybe work through it. And you can do it along with me or just watch. Either way is just fine. And so the exercise is just model at least 2 superheroes as data. And so you could say, well, Batman, how do I model Batman? So you might just start off with writing Eden and say, well, all right, I've got some superhero's name is Batman. He has an alias. Oops. Close up. I got a direct message.
Sorry, that's just me.
Oh, that's okay. Okay. All right. And so even now, as you get into this basic model, there are questions you might have like, okay, well, how would I model the power? Well, in this case, we're just going to enumerate them. So it could be a set of powers, it could be a list of powers, but in this case, we'll use a set. And well, you could use keywords or you could use strings, it's up to you. And so for Batman, his powers are he's rich, he's got a utility belt, and he's got a kryptonite spear in case he needs to battle Superman. Okay. All right, and then he has an alignment. And you could follow like the the Dungeons and Dragons 2-axis, or you could do like basic like good bad. We can say he's in this case we can say Batman is chaotic good if you want to follow that way of doing it. So he's doesn't always follow the law, but he's good. And then we can talk about his nemesis. So we can say nemesis, and then or we can do multiple. And then in this case, this is where things get a little interesting. You have to say, well, do I say his nemesis is Joker, or do I say his nemesis is like a map where the name is Joker? And that can depend on how you represent your data. Because if we're saying, well, superheroes have a name, well, what distinguishes the superhero from a supervillain? If we just say, well, supers, then maybe they all have a map whose name identifies them. And so perhaps that's the right way to do it. The bottom line, though, with this particular exercise, and it's a little fuzzy, kind of like the thing we did last time with the in our last talk talking about domain-specific languages, is this is really the time when you just want to kind of sit and think and figure out what is the right way to model my domain. So for this particular class or workshop, this is how I did it. So I said, all right, we've got Batman, he's got powers, and I'm just saying that's a set. His weapons are also a set. And then we have Batman, Superman, same thing, alias powers. Now, some of your individuals may have more than one alias or something, and so that's something to think about. Well, how does this fit into my domain model? But this is the model that I've come up with. And again, point number 1 is if you're new to Clojure, start with the data, don't start with the code, and then jump into the code after that. All right, now let's jump into our next section, which is talking about functions. So once you have a good handle on how to model your domain as data, then let's talk about how we manipulate that data. One thing that I think is really cool about Clojure is that Clojure really is I think, effectively a domain-specific language for data. Even though we think of DSLs as being very specific to a particular domain, if the domain itself is data, well then Clojure is a general-purpose language for modeling any data. So that's pretty cool. So we're going to interact with some of our data. So the first thing we want to do is inspect our data. The data sets here, if you're interested, they can be found on Kaggle. I've also got them in the project. So if I have this hero information, we can actually go look. So big CSV file. And there's a lot of junk in here, like there's hyphenated values for things that are not right. We have some numbers for like weight that are negative. So something's up with some of these things. So we're going to be doing a little bit of cleaning along the way. And so what we might do is we might want to look and say, so if you're following along, now we want to go to X02 functions, make that your active namespace. And so if we go in here and evaluate this, so I have my, my IDE set up so I can evaluate the form just before the cursor. Let's see. Yeah, if you need a bigger font, let me know, and I'll bump it up. I do have a big monitor, so so if I were to take this file, slurp it, call CSV on it, and then just look at 4 of them, this is kind of what it looks like. So very simple, very plain. We want to do something useful with it, and Clojure is great at manipulating data, so let's do that. All right, sounds like most people have a nice big monitor, so that's good. So I guess one takeaway is go get a big monitor if you don't have one. So the first thing we want to do as an exercise is we want to clean this stuff up right here. And so I have a function called remove bad entries. And we're going to go in a little bit reverse order because we define the smaller functions first and move our way down to the final parse. And so first function we want to do is remove bad entries. And I have a comment block here, if you're following along, that you can use to see what's going on. So I'm saying if I remove the bad entries from this map, and I've got a map with a key of nil, a value of nil for A, an empty string for B, and then C is okay. So I want to remove everything that isn't empty or nil, both keys and values. And so I want to make this just become C okay. So if you're doing a lot of Clojure development, what you might do is lift this block right here and just say like let M be this input right here. And then we're going to do something along the lines of this. And we're going to say, and what we want to do is we want to remove stuff that's junk. So, and we can destructure this. If you're not familiar with that, a map, when you turn it into a sequence, becomes a sequence of key value pairs. And so the K is the key, K is the key, V is the value. And so we're going to remove an entry if the key is nil, or if the value is nil, or if the value is empty. So if I do that, I get C okay. Now, one bad thing about this is in my test here, my comment, I actually want it to be a map that comes back. And so what I can do is I can say let empty, and normally you would put your lets all in, your bindings all in one let block. There's a reason I'm going to keep this one external. I'm going to say empty M, so that's going to create just an empty version of whatever the collection is. So empty on a map produces empty map, empty on a vector produces empty vector, and so on. And now I can say into E, and if I do that, then I get my map back. So let's go ahead, and what you might do then, and the reason I have this let form by itself is once you've manipulated it, you can come up into your code base, put it right there, and then all you have to do is change your let to defen, the name of the function you want, and then remove the binding on the let. And you have a nice function. And so now we should be able to say that that's true and that's true, which is sure enough, that's true. So we got it. Okay, now we want to be able to say, convert a sequence of vectors into a sequence of maps, assuming the first row of the vectors is a header row. In fact, when I was looking at the first workshop this morning, this is something that I did in order to take that CSV data and turn it into maps. And so we want to, again, do the same sort of thing where we convert a table into maps. And so I can see that I have a binding already, a destructuring binding here. So I'm just going to paste that right into my let form. And then I'm going to copy my data, my input data right here. And then just to show how that works, and this is cool, you can just interact with your data and see, okay, there are my headers. And I want to convert the data I have into, so these vectors into this map right here. And so what we can do is we can say map headers keyword, and actually, yeah. And then we can say I take all my columns and I'm going to map over them, and then I'm going to say partial zip map on the headers.
Max would like to know why you're using empty and not just into empty map literal.
Because if I do an into an empty, because if they, yeah, so let's back up for a second. So the question was, for this particular exercise right here, why do I put it into an empty version? Because without that, let's see, let's just do it real quick. If I do remove bad entries from this map right here, it returns a sequence of pairs rather than a map. But if I remove it here, then you know, it does what's expected because this is a sequence, this is already a vector. So what this is doing is it's taking the results and putting it back into the same shape of object as I started with.
It's not about the into, it's about the empty. Why did you specifically bind E to empty of M instead of
you know, what I really should have done probably was this right here. This removes the confusion about naming. And so I can just say I'm putting the results into an empty version of itself. So if I pass in a vector, it's going to go into an empty vector. If I pass in a map, it goes into an empty map. So I get the same data structure back.
He wants it to handle both vectors and maps. Yep.
Yeah. Cool. Thank you for the question. All right. So if I do this guy right here, notice I'm able to take this sequence of items, this square shape, and I'm turning it into a set of maps. So now we're going to do the same trick we did before. And we'll just say H, and then we will say map keyword headers, and then we'll do an H on that guy right there. And then now we've got our keywords. But now what we want to do is we want to map remove bad entries. And whoops, let's see. And I may, in my nervousness here, cheat and look at my solution. All right. Okay. So this is the solution that I coded up. And so I take my columns and I did what I was just working on. But then what I'm doing is I say, all right, we're going to zip our keyword as headers. And we're going to take each column and we're going to take each of those columns, and if it's a string, we're going to trim it. And so that cleans it up. And then finally, we're going to remove all the bad entries on it. And so what did I do wrong? Wes, my former coworker, has identified the solution just by inspection. So, all right. Okay, so there was something in my remove bad entries, there was something that in my solution I just worked on that wasn't quite right. So again, so here's the solution that I had originally coded up into the empty version. Remove things where there's, the key is nil, where it contains any of these for values. And so that's a little bit different than what I had before. So the nice thing now is I'm building up these functions. This isn't pertinent to superheroes or anything else. It's just parsing CSV data. All right, so now I have a function called CSV file to maps. And so I'll take any CSV file and now convert it into maps, which is pretty cool. I've also got a couple of utility functions that I've written that we're not really going to go over here. But one I call keywise or keywordized, which is replace all non-word characters with a space, including a sequence of them. So there's a whole bunch of spaces or a whole bunch of things, ugly characters. It'll replace that with one, and then it will replace ticks with, it'll eliminate those, and then produce a keyword. Maybe update is a function that if you look down here at the bottom, it says if the map has this particular key, apply this function, but only do it if it applies the function. And so conditionally, again, here's a map. If the key exists in the map, then we're going to update it, otherwise we will not. And then the bulk update version of this says take a map, a sequence of keywords and that function, and then reduce that. And so here's an example down here where I say maybe bulk update this map right here, and I want to convert width and height into doubles. And so I do a maybe bulk update on that, and that's what it does. Okay. So, and again, I apologize for the nervousness on the on getting my function on the live coding of the function, but this is something I find to be very useful. That I think that as you deal with data, if you're doing any kind of data science or just dealing with CSVs in general, other formats, you can make these nice little functions to take your data and convert it to something nice later on, something useful. So now let's jump into more interesting data. So now I'm going to go to section 3. So this is chapter 1 data, exercise 03 hero data. And so now we're going to start doing something fun. We're going to actually look at our superhero data. So I'm pulling in my CSV file to maps, my keywordized function, my maybe bulk update function. And so now let's go down to the comment block. And what I want to do is I want to take my hero data, and we can go down here to line 59, and I can just pull 10 of them. and I can see that this is what my hero data looks like. Just to show you what things look like if I just call CSV to map. So here I have my file name, the CSV map to, or file to maps function we just developed, and let's just take like 10 of them. And so here we have keywords, and then everything is strings. And so what I want to do then is I want to call the normalize function. And the really cool thing about this is this normalize function, aside from these 1, 2, 3, 4, 5, 6 lines of code, everything I have is completely reusable in this original namespace, and I'm going to use it across the board. And so what I want to do is say, all right, for height and weight, those are double fields. And for these fields right here, those are keyword fields. And then I'm going to do this maybe bulk update with my map that says, with this map, if these fields exist, make them doubles. If these fields exist, make them keywords. So let's look at just one example right here. So there we go. So we're starting with this map, and we end with this map right here. All right. Now, here's our heroes data. Again, looking at some of those, that's the way we want it. And so now one thing that's really cool is we're now in data land and Clojure land. And so we can start doing things that to kind of look at our data and understand our domain model a little more. So one of the exercises here is compute the frequency of names if the name occurs more than once. So if you're sitting there by a REPL, go ahead and try it out. So we've got heroes data. And so I'm going to say, all right, so what you're probably going to do is want to do something like map name. And sometimes if there's a lot of data and you want to put a little governor on it, you can just say like, take 10 or something like that. And so there's our names. And then I can say frequencies. And those all occur one time. And I really want to know if they occur more than once. And so what we're going to say is we're going to do remove anything where we have, again, here's our key value. We're going to do a destructuring along the way. And we don't really care about the key, but it's the value we care about, the frequency. And so we're going to remove it if the value equals 1. All right, that's empty. That's what I expect because that was just a small sampling. Okay, so I was able to look and see that I may have some data quality issues. I have 3 instances of Spider-Man, a couple of several other ones. Some of these superheroes I've never even heard of. All right, so now let's look at another example here. So it says, given a hero name, determine the duplicate values associated with non-distinct keys. So this is kind of weird to describe the problem, but if I have something like what we see down here on line 84, I have 4 maps with the name Mark. And then 4 of them have ages, but 2 of the ages are the same. And then 2 of them are distinct. And then I have 2 distinct heights, but I only have 3 heights. So what I want to do is figure out how do I compare that, or how do I reduce that down to just what's different. So I want to produce this age of 12, 14, 16, and a height of 100 and 101. So I only want to see what's different. So let's try it out. So here's a hint. We're going to use Clojure REPL and merge with. And so merge with says returns a map that consists of the rest of the maps conged onto the first, but then there's a merge strategy if they're the same. So once again, we're going to go over to the REPL. And merge with takes a sequence, or it takes a variadic list of maps, not a sequence of maps, not a sequence. So we're going to do apply, and then we can say merge with, and just for fun, whoops. I have to have 2 arguments, A and B. So this is the item that's in A, the item that's in B. And what we'll actually do is we'll say vector AB. So that's interesting there. So what's happening is every time I get an entry from A and an entry from B, it's just going to put it into a vector. And so we have a vector, and then we get another one later on, and so that stacks into another vector. But this actually kind of gets me kind of along the ways of where I'm trying to go. So what I can do is I'm going to do a thread first on this guy. And then I can say map, and we're going to use the same syntax. And we're going to flatten out our vectors. So now we have this. I really want to know the ones that are distinct. And so I can say, all right, well, let's see. Okay, that's getting me a lot closer. And then at the end, I did say I want to put it back into a map. And I know it's going to be a map, so I'll put that on there. The one thing that's missing is I don't care about the ones where there's only one. And so what we can do then is we can say remove, excuse me, where the count of v is equal to 1. All right, so it's pretty cool. So I can take this function, and once again, I can go and I can say, put it right there in dupes, and I can put maps right there. So I'm promoting my little mini analysis up, and I can find the duplicated data in here. So I can do things now where I can say, all right, now that I've done this, let's take dupes of, let's see, heroes data. And we're going to filter I think it was Spider-Man that had duplicates. Actually, we already know that right here from this one. Spider-Man had the most, and that's hyphenated. Okay, and now we're going to put it through dupes. Okay, so Spider-Man has 3 entries, and we ran it through here, and we see that where we have conflicting values, we have different weights, 74, 77, 56. Those are somewhat varying. Hair color, brown or black, I guess it depends how dark his hair is. And then various eye colors. Red is kind of interesting. Maybe it's an alternate universe Spider-Man. And then the heights are also a bit different. So it's pretty cool. And so as you analyze data in Clojure, what you'll do is you'll start with that data as model, and then you'll build these generic functions to manipulate things, and then lift them up to functions later on. All right. And then here are the solutions that I produced. They're probably a little bit cleaner since I had time to think about them a little bit. So now let's actually look at our power data. So we've got 3 source files that we're going to pull in together into our final product. So now we are in exercise 04. And so we have a different file that we're going to look at here. And once again, I'm just going to take the powers data itself. And before I normalize it, I just want to see what it looks like. Okay, and so right off the bat, right out of the box with my function I already had, I get these sequences of maps, and they're very long. And if you look carefully, everything is a Boolean. It's the name of the power, and either true or false is a cap string. And then somewhere here, there we go, hero name, Agent Bob, or hero names, Agent Bob. And so there is a hero names key in there as well. Well, what I want to do when I normalize it is I want to take one of these hero maps, and I want to make a more compressed form of that. So that, did I do that right? There we go. So what I'm going to do is I want to take my hero and I want to put the name in the name as a name key, and then I just want to have a set of their powers. I don't care if it's power true, power false. I just want the set of powers. And so now what I can do is kind of examine my powers, and so I'm starting to have some useful data that I can merge together with my previous data and do some interesting things with. So now here's a little exercise. It's already kind of completed, but we can just kind of see some of the things you can do. So I can take my powers data, which is quite a bit, and I can filter it by saying, all right, who has flight, who has super strength, who has X-ray vision. And so these are people that have all of those powers right there. So what I'm doing is I take my filter, I get the name, the powers is a set, and then I'm just using set as a function to do that. All right. Now let's look at, and once again, just to kind of reiterate, with each of these, the reading in of the data is just a few lines of code, and then it's really the only bespoke work I have to do is this normalize function, which is pretty small. Finally, we have some supplemental hero data. The supplemental hero data is ugly. And so I'm not going to go through the exercise of showing how I parsed everything, but just to show some examples of what the supplemental hero data looks like. In fact, we'll just take one. It has the creator, the team affiliation, both were they the leader of the team, is it a former team? What were the occupations of the individual? What are the various stats? These are more like you're familiar with, like your Dungeons and Dragons stats, where it's a name and a value, only it's a, it's not a 3 to 18. And so, it's interesting, but once again, there are a fair amount of data that went into the normalization there, but thinking of Clojure as a domain-specific language for data, everything here is just data manipulation functions. There really wasn't much to it. And so here I have an exercise where I said, all right, let's find all the relatives, find the first relative, and then see what the distinct relative relationships are. So, or who all the relatives are. So I was just playing around with this. I ended up really doing with it in the exercise, but it's kind of interesting. I was hoping for very uniform relative relationships, and unfortunately they're not. They're like, brother's son-in-law, or mom's sister or something, instead of just uniform names like aunt, uncle, or whatever. And then finally we have a Yoda quotes one. The cool thing with the Yoda quotes, okay, the not cool thing with the Yoda quotes is I did not end up incorporating it into the final database that we're making. But the cool thing is no special preprocessing was required. It took it right out of the box. And so if you want, at some point, you could normalize the name Yoda character to name, and then you could merge that into the datomic data set that we're going to, or the data script data set we're working with. But that's it for right now for that. So that is our first chapter in this exercise. It's just kind of going through this idea of start with data, understand the functions that manipulate data, build, manipulate those functions, and then when you get them the way you like them, or those manipulations the way you like them, lift those up into a function. And that's a very common way of working. After a while, you're going to have a bag of functions that are very useful for whatever it is you're doing. At some point, the queries and the data manipulation you're going to be doing are going to get a little tedious if you want to analyze complex relationships, particularly if things are a little bit nested. So at that point, you're probably going to want to have something a little more sophisticated. And so now we're going to talk about my favorite database, or favorite, I should say, family of databases, which are I don't know if there's a specific name for them, the data log databases, but there's DataScript, DataHike, Datomic, and Crux. Crux is a little bit different than the other three. The other three, actually, their query syntax and a lot of their basic concepts are very, very similar. In a lot of ways, you can write things that are API compatible across the board. So let's talk a little bit about these databases. So what's neat about them is, and if you're following along, go to this Chapter 2 data log, exercise 00 basics namespace. And the first thing we want to do to understand them is I can step right here to line 7. And if you have the ability to evaluate an inner form, you can do that and see that an empty database is a schema and datums. And datums are really the thing that makes these magic. And we'll talk about that a little more in just a minute. I can then take this empty database and I can say with that database, dump in these 3 objects. And so I have name, favorite food, age. Notice there's no spec, there's no requirement of any particular keys. And so I'm going to dump that in. And the datums that are produced are these 4 tuples. And I'm guessing that most of you there's probably a few of you that have some experience with Atomic or DataScript. I'm guessing most of you do not, so I'm gonna, if it goes a little too fast, please review the notes after, but I'll try to explain it in as concise of a manner as possible. So datums are really, oftentimes we associate them as being facts. And the idea is a datum is a 4 tuple, and in that 4 tuple, the first item is the entity, and the entity is generally just an ID. So it's going to be some integer. The actual ID itself is not that important because the system will keep track of that for you. And then the next thing is an attribute. So in this case, the attribute is favorite food. And then the third item is going to be the value associated with that. So in that case, pizza. And then finally, the last one, and depending which technology you're working with, it may be a 4 tuple, it may be a 5 tuple, it just depends. But this is a time, and so this is associated with the time that the fact entered into the system. And there may be additional values for things like, was this datum transacted in or was it retracted out? And so the reason we call these facts sometimes instead of datums is when you think about a fact is some attribute, it's some value associated with an attribute of a thing in time. And so you could say, you know, 3 is not a fact, but favorite number 3 is getting there. But if I say Mark's favorite number, the entity is Mark, favorite number is the attribute, 3 is the value. And so, or you could say, you know, Mark's favorite food is pizza. And so that's a fact. And so that's how these are captured. Where time comes into play is over time that might change. Today, my favorite food is pizza. Tomorrow, my favorite food is macaroni and cheese. It just depends. And so as you assert and retract those facts, you may have a temporal aware database that's able to keep track of that. In this particular instance, DataScript does not have any kind of temporality like that. Datomic and Crux do. And in fact, Crux is bitemporal. It knows both when the information system knew about something as well as when you assert in the universe that something is true. All right, we talked about this, the EABT, so those are called, that's often what we call the entity attribute value time tuples. And then finally, we have queries, and queries in these databases look kind of like this. They are data, and we had a talk earlier, a workshop about domain-specific languages, or data-driven domain-specific languages. And these queries are cool because they're all data, so they can be manipulated programmatically. You just write them out as data. You know, they're much more rich to interact with than strings. In this case, I have a database. I can look at my database. Entries right here, I can just dump it and see. And I'm going to say find something n. I'm not specifying what n is, it's a symbol. Find n in $, and that's just a convention for in my database, where there's an entity whose name is n. And so I can look at my tuples here, and I can see positionally that E lines up with these 1, 2, and 3. A is named, so there is 1 has a name of Mark, 2 has a name of Pat, 3 has a name of Chloe, and then N is the thing in that position. So if I evaluate this, then I'm going to get Mark, Pat, and Chloe. So I'm going to pull the names out. Something else that is really neat about, let me make sure I'm not jumping ahead. Yeah, okay, this is just right. So now that we've seen kind of what a fact store looks like and what the queries look like, let's jump into how schemas matter. If you're familiar with databases like SQL, schemas are at the record level, so they're at the row levels. And that can be challenging because if you're saying, I have a superhero database, then that implies that a superhero has certain attributes. A superhero has to have, you know, maybe it's a name, an alias, and a power. Or maybe it's a name, a home planet, and a nemesis. That, you know, you really got to figure out what are the set of attributes that make a superhero if you want to use traditional you know, modeling like in a relational database like SQL. And so that can be very challenging because it's hard to know all the attributes right up front. On the flip side, you have document databases like Mongo. And so those typically are schema free. Excuse me. You just dump your data in and you know, you'll put an index on a particular key and that's it. So there's not a lot of really rich query capability for doing unioning and that sort of thing. Data log databases are kind of in the middle. They're in this really sweet spot where the schema is at the attribute level. And so when I say something, I'm going to say name is a string. I'm not going to say who has a name, what has a name. I'm just going to say if name exists, it's a string. I'm going to say that powers are a sequence of keywords, and that's it. And I'm not going to say who has powers, what has powers, and you basically just allow the database to assemble those facts together and to have coherence. So let's look at how schemas work in these databases. Once again, we have an empty database. I'm just going to put Batman, Bruce Wayne, some of the stuff from our earlier exercise in here. And you can see that if I do this, here's our database, and there's no schema, and I have one entity that I put in here. Notice the name, there's only one along here. And its alias is Bruce Wayne. A couple of interesting things to point out here. The nemesis, I have a nemesis, which is a vector of maps. The nemesis just went in there literally as a vector of maps. It didn't do any kind of exploding of the data or anything like that. Same thing with weapons. That just went in as a set. So it went in literally as I put it in. And we will fix that in a minute. Let's try something else. What if I transact multiple names? And I've got Batman, Batman, alias Bruce Wayne, alias Bruce. All right, so if I do this, notice that now two datums are created. I have this entity and I have this entity because there's no concept of uniqueness here. So we need the ability to put schema on our databases. So now let's look at schema, how it works. So a data script schema is a map where the keys are the attributes and the values are the schema for the attribute. So in this case, we're going to say that names are unique and they establish identity. We're also going to say aliases are unique and establish identity, and that you can have many aliases. We're going to say powers have a cardinality of many, so I can have many powers. Same thing with weapons. Nemesis here is interesting because I can say I can have many nemesis, and a nemesis itself is a ref. And a ref means if it's a map, it's going to turn that map, it's going to explode that out into more datums and put that in the database as additional entities. All right, so now let's take our previous example and let's evaluate it with this schema right here. So if I make an empty one of the schema, notice there's my schema. And now I'm going to transact this information. And when I do that, I've now created, and this is really interesting. And in fact, I'm going to remove one just to show what's happening here. So I'm only putting in one map, but 3 entities were created. And that's because name establishes identity. And notice Joker and Penguin have names. And nemesis is a reference. So nemesis, it's going to look at this and says, oh, it's cardinality many. It's a sequence of maps. And those maps have a name. And that name means identity, has identity. Therefore, I'm going to turn this into more entities. And so on the fly, it knew to explode all that out. But what happens if I have Batman in there twice? So if I do this, notice I still only get 3 entities, but my alias is, and I said alias right here as a cardinality of many, and notice I have an alias of Bruce Wayne, an alias of Bruce. Notice I now have 2 aliases for Batman. Both of them went into the system. Now, if I were to remove the alias cardinality many, it should just overwrite the old one. And so in this case, the only alias is Bruce. I lost the Bruce Wayne one. So if you see the same entity multiple times when transacting, the question you have to ask when you have attributes is this a replacement of the old one, or am I accreting more and more information about it? And here, in fact, I'm doing what I just talked about. I take my schema, I remove the alias from it, and now when I transact the information, I am overwriting the alias, and I'm overwriting the hair color. I'm replacing the hair color from Green to Black and Bruce Wayne to Bruce. All right, and our final segment on schema, we're going to talk about data hike and datomic schema. So data script schemas, another thing that's interesting about data script is it's exceptionally forgiving unless you must say something about it, like it's a reference or it's an identity or it's cardinality. Data script, you don't need to, in fact, in many cases, it will not allow you to assert anything. You just throw stuff in there, it disassembles everything, and by and large, it just works. Data hike and datomic, on the other hand, require you to make assertions about every single attribute in the system. And I would imagine for a large, durable system that you're going to want to be keeping around for a long time, not just a quick and dirty study, you probably are going to want to have something more like that, where you make assertions about all your attributes. So the difference here is, in addition to having to do that, is your schema, instead of being a map, is a sequence. And in that sequence, you're going to have maps, and the attributes here are the same as in DataScript, but then you're also going to have this DB ident. So instead of being a key, a map with a key value, it's going to just be a single map with an ident, and that ident attribute is the key. And so here I went through and I had to make some decisions. I said, all right, names are unique and there's only one name. Aliases are strings. They establish identity as well. And there's many. Alignment is a string and you can only have one alignment. You can have many powers and they're strings, many weapons and those are strings, many nemesis and those are references. And so there is a little exercise here and you can just pop it up in the chat if you see it. And before that, I do want to point out when you use data hike, so data script, you can just do inline. It's very nice. It's in memory. Data hike is backed by, it's file backed. And so you create a connection to it. And so I have this connection from directory. And then, and that's a utility function that I have. And you can go look at that later. So I can transact the schema in. And then if I transact the data, notice it's going to break. And so can anyone pop up in the chat and tell me why did this fail to transact? All right, we got a comment. Right, no schema for hair color. And it's kind of cool because when you look at it, it even tells you, oh, bad entity, hair color. Okay, so hair color, we're going to say, is a keyword. And so it is similar to, we'll just say it's kind of like name. And so we're going to say hair color. Its type is keyword. It is not identity. And its cardinality is 1. So this should be correct. So I'm going to retransact my schema. And then I'm going to transact the data in. And sure enough, it works. So it's all there. If I call cleanup, it will delete all this stuff in my database. So that's everything transacted in. Okay, now let's look at queries. This is where things get a lot more fun. So we're going to use this database, this DataScript database right here as an example. And so, let's see, I have a comment. Can Batman be his own nemesis? Let's try it. I think he can. Nemesis name. All right, Batman, nemesis. Oh, and by the way, nemesis are, because it's a reference, it's going to point to the entity number. So the nemesis of Batman, Batman's number 1, Batman's nemesis are number 1, Batman, number 2, Joker, number 3, Penguin. So pretty awesome, right? All right, now we're going to talk about how you get data out of a DataScript database. And again, I'm using the database technology name liberally. There is the pull API. The pull API says, if you can tell me an identity or an entity name, an entity identifier, like 1 for Batman, pull information out of the database about it. So in this case, we're going to pull 1, and 1, if I pull it, is Batman. Notice, hang on a second. You want to put, there we go. I want to we're going to transact our new data in, so Batman is his own nemesis. Now you can do something called a lookup ref, though. So I'm providing number one, but you're never, in the real world, you're never going to be like, oh yeah, go tell me information about ID number 57. That doesn't make any sense. So there's this thing called a lookup ref, and any attribute where you've transacted, where in the schema you've said that the attribute is unique, whether, and so it's a unique, or a unique, make sure I got my wording right, unique identity and unique value. So right here. There's also your unique identity and unique value. Unique identity you can upsert on, unique value you can't. Once it goes in, it's immutable forever. So anything that you say is unique, you can use what's called a lookup ref on. And so Batman, well, name is unique. And so I can say, all right, I've got a name Batman. This pair is a unique thing. I can use that to look up Batman. So I can go and pull Batman out that way too. And that's the way you would probably do it in the real world. You're probably never going to use like number one, unless Batman's always number one. All right. You can also, in the syntax, this tick star, this is just preventing it from trying to evaluate star, but this says, give me everything. You can also use in the pull syntax, this kind of reverse notation where you say, give me the name, give me the nemesis, and the name of the nemesis. It's going to be kind of interesting because Batman has a name of Batman. His nemeses are Batman, Joker, and Penguin. All right, so that is the pull API. Of the three APIs I'm about to describe here, I will use pull probably the second most. Let's see, what do we got? Ha. Got to show Batman some love, right? Okay. All right, now entities, and entity API works with data script, data hike, Datomic on-prem. It does not work with Datomic cloud. Yep. So entity is kind of interesting. So I'm going to evaluate the inner form, not the outer form. In fact, to make it clear, let's just go to right here. So I'm saying from my database, pull the entity whose name is Batman. And I get back number one, but it's just this hash DBID. And that actually is a, let's see, I think the type will tell us. So that actually is an entity. It's not, so the graphical representation doesn't tell you everything. And so it's almost like jumping into like a graph, like you're like, you know, really cool navigation where you're jumping right onto that node in your database, and then you can navigate from it. So I can go there and I can say, give me that entity and get its name, and its name is Batman. Or I can say, get the entity, and I can say, give me its nemesis. And then the nemesis of Batman returns a set of 3 more entities, which is awesome. And then I can also say, all right, there's this thing called a back reference, which is you take the keyword and you put an underscore in front of it. And so you don't have to say like, you know, nemesis and like anti-nemesis. You don't have to create a bidirectional linking. It's already done for you by using a back reference. So this is saying who declares Joker as a nemesis. So if I do that, then it's number 1. And so I just exercise how might you modify these 2 queries to get the names of the nemesis. So it's fairly straightforward. But I'm sure if you're new to Clojure or DataScript, maybe it's like, this still seems kind of crazy, but you can just say map name to get the nemesis, right? So you're basically walking a graph, and then as you walk the graph, you can grab the attribute. So it's pretty awesome. And so the one really cool thing about this is if you think about like the, you know, there's the new like Datafy and nav protocols, or even if you're not using that, you could write some tooling where you actually create a graph, and it's implicit too, right? Just in your schema, you're saying, I've got a name, like let's say you're talking about like family trees or something. You've got, you know, a parent-child relationship, and all you do is assert information, and then you could create some tooling where you actually walk the tree using just the entity API. That would be like a super awesome application. All right. And that's probably the one I use the least, but for applications like that, like if you want to do like a natural tree walk, it would be, you know, it's awesome. The last one is the most common API, which is the query API. And the query API in all these is just called Q. And so the cool thing about your queries is they're just data. So this right here, again, there's no function, there's no nothing else, it's just data. And so I want to know who the nemesis are. So we can inspect this and we can say, all right, I'm going to find the name of my enemy. And again, these are just symbols. I can call them whatever I want in my database. So this takes 2 arguments. This query takes a database by convention is a $sign. Everything else has a leading question mark and an input name. And then I'm going to say there's some entity E that has a name that I passed in. And that entity E also has a nemesis. And that nemesis I'm going to assign to the symbol N. And that N, so it's an entity, and that N has a name as well, and that N would happen to be the entity name. And so that's how data log queries work. It's just logical, kind of set operations. So if I run that now with this, I can say, who are the nemesis of Batman? And I get Penguin, Joker, and Batman. And I was able to pass this guy in. All right. Time for an assignment. And again, if you feel up to it, work on your repo while you're listening. If not, just follow along. So we're going to write a query to list the name and alignment of all individuals in the database. Okay, so I've got this ... here. We can replace that. So typically what I want to do is I will say, all right, the first thing I want to do in my find spec is figure out what's the thing I'm looking for. Well, I know I need a name and I need an alignment. Some people, when they write these queries, prefer to use really short names like question N, question A. I like things spelled out a little more. It's easy to have things that you can come back to and see later. And so we're going to say in the database. Now notice the database itself. Let's see, we probably got a comment. Yeah, right. Brevity is not always awesome, especially when it comes to naming symbols. All right, so what I want to do here is I'm only passing in 1 argument. In fact, let's change this up just a little bit as a placeholder. Okay, just for illustration, I've got this query that takes my database. Okay, and I want to find names and alignments in that database. So there's only 1 argument where there's some entity who has a name, and that same entity also has an alignment. All right, let's see if this works. All right, so Batman is chaotic good, so we got it. To make it a little more interesting, and this is one thing that's fun, is I will frequently, like if I'm doing heavy duty lifting, you're in production, you probably want to do like, data hike or datomic. But if you're just experimenting, because they're generally API compatible, I will frequently write all of my queries in data script because it's really fast. I can just embed all my data right there in the REPL. And then once it's good, I just, I can keep my queries separate since it's just data. So now we're going to go in here and we're going to say, we're going to take my database, and on the fly, I'm going to say, with this database, DSDB, I'm going to add in Joker with an alignment of chaotic evil, Darth Vader with an alignment of lawful evil. So, and if you would like to debate the alignments of the Joker or Darth Vader later, that would be a great chat. But I think that's what I'm going with. And so you can return the results right there. So it's really easy to take your base database and just throw some other data right on it with data script and then just kind of mess with it. So it's pretty awesome. Okay, so that is the basics of queries. Here are the solutions right here. Should you want to look at it later. All right, now let's look at our schemas. So I already showed you in the previous chapter, we went through the work of getting our hero data. So we're going to go down here and we're going to down the comment block mostly right now, and we're going to pull in my hero data as well as the data hike API. So now that I've gone from experimenting to let's do something with it, I'm going to promote my database to data hike. So I've got this connection, and in case you're wondering, if you're following along, there's a TMP folder right here on the left that has all of my databases in it, or that's where data hike puts all the databases. And so now let's look at the schema right here. So I have this, let's just look at it. So there's schemas, data hike, hero schema, schemas, data hike, hero schema. So here it is. And what's cool about this is it's just data. I can store it off in a file. I don't have to be all like inline or anything. And so I can look, and these are all the attributes from those 3 data sets we're going to use, the attributes of the first data set. And you can look at those later. You don't really need to go over every single thing. And so what we want to do is we want to transact that in. Oops, and let's get a reference to it. All right, we got our connection. Now we're going to transact it in. So my schema's in, and then I'm going to transact all of my data. Most of these I've already transacted, and I'm probably not going to go through the exercise of retransacting everything, but on your own, everywhere where it has like transact all the data for your own exercise, you might want to do it if that way you can follow along and put the data. So we're going to use the pull API, and we're going to say, all right, from this API, let's find out what we know about Spider-Man. All right, that's what we got. And this is, again, this is from our very first data set of the 3 data sets we looked at in chapter 1. If I were to call cleanup on con, it would blow away my database. I want to keep it just in case. So now let's look at our second schema. So now we're going to go to X04 hero power schema. Oh, one thing I forgot to mention, it is very common, at least when I'm working with these databases, is you're going to have your original data right here. It's like take 3. And maybe you're going to want to make some little modification to it. And so what I will do is I'll usually map over them, and I'll have some kind of a single function that coerces the data as needed to make it work. For example, publisher right here is a string. And in my schema, I said publisher was actually a ref. And so when I do that, and this was just kind of my own definition of how to do it. But you know, the schema is up to you how you want to interpret your data. Again, it's all about thinking about what's the right way to model my data. And so I just wanted to transform it like that. And that's the only thing I had to do to make it schema compliant. So in this case, because name establishes identity, both from a publisher as well as an individual, I could do things where I could say like, are there publishers that have the same name as a superhero or something like that? You could potentially have name collisions too. Again, that's just kind of beyond the scope of this talk. All right, so now let's look at exercise number 4. And so now we're going to look at our schema for hero powers. And so I'm just going to dump that right there on at the console. And so hero powers is a very simple schema. It's just the name of the hero, which establishes identity. This is really important though, because now in my last namespace, that same block, ident name with the value type unique, that's the same for that data set as this data set, which means with no effort whatsoever, if I were to combine these two, hint, hint, we're going to do it, into one database, I get a free union of all of that data without having to go and figure out like, you know, what are my foreign keys and my inner joins and, you know, whatever else. All right, powers, we're saying is just a keyword, and you can have many powers. Very simple. All right, so now let's go down here and make sure everything is working. I'm going to look at my connection, and I'm not going to transact this because it's sure to be transacted, but if you're following along, you'll want to transact, you'll want to run these 2 lines once you run this first one on line 13. And so now I'm going to pull Spider-Man, and I see that Spider-Man has his name, and then he has a list of powers. So first one had other stuff, this one's got power stuff. All right, so now let's do some queries, all right? Who has levitation? Because that would be a cool power, right? So I'm going to say find, let's see, we want to find the name of an individual that has the power of levitation in, and I see that I'm passing in 2 arguments. One is my database, and the other one is a power. And then I want to say where the entity name is name, and the entity's power is power. And now notice, so I'm unifying the entity on entity name, which I do not know, I'm trying to find out, and the power, which is being passed in. So, all right, what do I do? Oh, I even have a hint to myself. The attribute is power, not power. Okay. Note to self, read notes to self. Okay, so there we go. And there's a convenient syntax in data script where you can go. Datomic Cloud doesn't allow this. Hopefully they will at some point. But it's just a convenience where if you're producing a vector just of one item things, scalars, you can just get a sequence back. So these are things that have limitation. All right. Who has the same powers as the named superhero? Return a map of power to sequence of names of hero with shared power. So find out the powers that a superhero has, find out who else has that power, and then return a map that has the name of the other individual along with their powers. All right, let's do it. Yes, it is powers. Got the comment there. Name and power. Yeah, what I'm going to do is keep things a little bit simpler. I'm going to remove the reduce just for now. So I want to know names and power in the database with the name where we have some entity whose name is, and let's actually call this in name. And I think this is our first like super awesome query. I think it's gonna, you know, hopefully you'll be super impressed by the result. All right, so we have a hero whose input name is name, and their powers are power. We also are going to have some other entity whose powers is power. So we're going to unify. We're going to say, find this guy here, this individual, and we're going to match on power and get some other individual whose name is name. All right, and then we're going to return name and power. And one thing we don't want to do is we want to say and not equal in name and name. So I don't want to return Yoda in this case, my hero name. All right, cool. So this is my response. This is my results. So now let's do a little reduction to kind of gather some of the results together. And so if you look at these powers on the right, they should all be powers that Yoda has. And so here we go. So scroll up, Yoda's got a lot of power. So stealth, apparently Yoda has stealth along with Black Manta, Captain America, and Vixen, and jump, and agility, and so on. All right, let's do one more fun query. List heroes by number of powers. Who is the most powerful hero by sheer number of powers? Okay, let's figure it out. All right, so we're gonna say find name, and there's this cool thing where you can do these aggregates. So you can just say count power in my database. By the way, one hint is if you're doing these queries, if there's only one argument that's being passed in, and that's the database, you can drop the in $ clause. I always like to leave it just to be explicit. And then we're going to say name is name, and powers is power. All right. And then I also sort by the second value. So I sort by this. So Spectre, I don't even know if I know who Spectre is, or Amazo, or I got to go all the way to Martian Manhunter before I even know who some of these people are. Apparently the TX and apparently Terminators have a crap ton of powers. So whoever wrote this database must like Terminator movies. So, all right. Here are the solutions. Now let's jump to exercise 5. Supplemental hero data. One thing, again, with as with the previous chapter, this one we're going to just kind of more skim over because there's a lot more manipulation that had to be done to assemble these together. But mainly we're just going to put it in because it's going to be more interesting later. But we can get our schema, can get our connection. What I should say, that was our, let's see, there's our schema. And so this is the schema for that third data set, which is the most complicated. So just to show you what's kind of in here, on line 49, if you pull Spider-Man from there, let's see. There we go. So if I pull Spider-Man from there, notice that the last couple had a little bit of data about Spider-Man. The last one just had like a name and powers. This one has height, relatives, stats, where he's based out of, aliases, a bunch of aliases. So Spider-Man's alias is Green Hood. Interesting. You know, somebody wrote a lot of comic books when putting this together. I thought I knew all about this stuff. Okay. But aside from knowing we have the supplemental data, we're not really going to dive into that right now. So now that takes us to exercise 6. And this is where things get even more interesting. We're going to take our final schema where we say, all right, we're going to take our exercise 3 schema, our exercise 4 schema, and our exercise 5 schema, and we're going to concatenate those together and then get distinct values. And so that is our final schema. And so there it is. And you don't need to, you can look through that later. Not super exciting, but what's cool then is I have the ultimate database and I can transact in all of these. I am not going to transact in all this data right now. It takes a minute or so, but if you're following along lines 28 through 33, you're going to want to sequentially transact each of those so that all your data is in there. And I do keys here. If you're transacting a huge amount of data, sometimes the return is massive, and so it's nice to just put like count or keys or do a let binding and bind it to underscore or something, just so you're not dumping that out into a REPL. And so if we count our database, we have 58,000 attributes in there, 58,000 datums in there. So now let's see what Spider-Man looks like. So Spider-Man has all this stuff now, right? Because we have, this is from before, we have powers that came from our previous two namespaces ago. And then we have the stuff from the original as well. So pretty cool. All right, the last section in the data log section of our chapter of this tutorial is talking about just getting into some of the more interesting queries. Now that we've got all this data, and again, implicitly joined just by the attribute schema, which is awesome, we can now do some pretty cool stuff. So we can build this useful library of queries. Again, it's just data. So here's an alignment query. I think that's something we came up with before. So find the name and alignments of everything in the database. Find the distinct alignments. So I could do this to find out, like, if you were to say, well, what are all the hair colors? What are all the alignments, in the database? You could use that to find it. Our nemesis query, shared powers query, we did that one already. All right. So now let's go down to our exercises. So write a query that determines all values for an attribute where the type is schema. So you want to know basically like what are all the eye colors in the database, or what are all the genders in the database. I use Clojure test for like unit testing. When it comes to like system integration testing, I can't say I'm a master at that. I do think that Clojure test is great for your example-based testing, and I will use like spec and generators and do generative testing when I can. I think that's super awesome too. But yeah, usually it's just Clojure test with spec as well.
Let's give it a few minutes in case people are still thinking of questions or things to ask.
Sure. Let's see. One thing too I will comment on, so Wes said data hike is nice for local tinkering or long running data heavy, et cetera. I will say, for a lot of the things we do, we have this view of what big means. And I found that, I'll have some file I'm trying to analyze and it's, multiple gigabytes or something like that. And certainly at enterprise scale, that's not that big. But it may be that you initially are like, oh, I need like Datomic for this. But data hike or data script or data hike, they actually have very good performance as long as your data will like fit in memory or on the disk. They're surprisingly good for almost everything I found. There have been very few times when I've tried it, with realistic expectations where it fell over.
I think Sam had a follow-up question, if I understood that correctly, where he says, I was leaning more towards use cases, but I'm thinking data hike, Datomic, and relational database can all accomplish the same thing, provided you've modeled your data appropriately.
So, maybe I think I'll say it's sort of like saying, if the language is Turing complete, it's all good. I think that there's a data hike and Datomic work well together, but they really have a significant difference from relational. And I think the biggest difference is that relational, you're modeling your entities at the record level, where with data hike and Datomic, you're modeling at the attribute level. And in fact, in my notes, I have a reference to that talk, data script and Datomic data modeling for heroes. But I talk about, again, I use Batman as an example, but, it's easy to say, there is a thing and the thing has, has a utility belt and the thing has two legs and the thing has a cape. And I mean, it's very easy to describe entity, and that works in real life too. And, but to come in and say, there's a superhero, then there's an expectation. I just turn the problem around and say, okay, well, a superhero has to have, it has to have powers and it has to have, nemesis and these things. Like, well, wait a minute, Batman doesn't have any real powers. Is Batman a superhero? Or you could say, superhero is a person. Well, is Wonder Dog a person? So is Wonder Dog not a superhero? And so, when you're talking about relational databases, you do kind of fall into some of that same slot-based thinking that you would have with object-oriented programming, where when you're really talking like attribute modeling, then it's just like describe the thing. But again, it's all about establishing identity. If you're describing a thing and you don't really know what to attach that attribute to, you've got a problem. So yeah, it just kind of, again, just kind of evaluate, what's the right tool for the job. I've noticed also like time series data, there's some other things where just kind of corner cases where it can be challenging doing one versus the other. So yeah, great question, Sam, and others. Yeah, modeling a graph, that's actually something that's kind of cool. I did not talk about like Neo4j or like graph databases here, but these databases actually work really well, especially if the entity API is working for you. Like if you can fit everything in process and you're using like data script or local data hike, then and you have the right references, And I mean, think about the ability to just like navigate anywhere in your system from where you are. I think that is like it's just an awesome thought. I haven't built something like that yet, but I want to. I need more. I need to level up my front end skills. Yeah, Rafael pointed out a good, made a good statement that you know, there are certainly like performance issues and stuff. You know, database performance, for example, like, you know, Postgres, you know, some of the old school relational databases. I mean, they're old and battle hardened for a reason. I mean, they definitely have exceptional performance. They do what they do well. I know that, anyways, yeah. So I mean, really for your application, for me, frequently, if it's like a small application, I'm just getting started, I may default to one of these. And then later on, it's like, okay, this is too big. Another strategy might be to say, well, can we partition, is there a natural partition of our data to say that, all right, I can't get all of my customer data in one database, but what if instead I was able to just do a natural shard by saying every customer gets their own data hike instance or something like that, then you may not have performance issues. But yeah, it's kind of getting down to the, you know, why one versus the other. Well, I'm curious, is there anybody here who is using any of these in production? I know if somebody asked me that, if you're using a data-stripped atomic data hike in production, I'd be curious to at least see a thumbs up or something. So Rafal uses Datomic on-prem as a backend for Braid chat. One important point is that the order of the statements doesn't matter. I mean, theoretically, it's all like, you know, it's all just like logic operations. And so, you know, if you say, like, you're saying name and powers, and then you want to bind that or unify that with somebody else's powers and name or something like that. Theoretically, the order does not matter. That actually is, that's only theoretically. In practice, what you'll want to do as a good rule of thumb, as I talked about, things that have uniqueness or identity, you're going to want to put those things up front because, hang on just one sec. You're going to want to put those things right at the very top because there are things that are very fast to look up. So anything that is like unique identity is essentially, you know, constant time lookup. It's just, it's all indexed. And then you'll want to reference off of that. But if you do, because some things are going to require like a full database scan if you start there. So.
There was an interesting link that the James just posted where they had a query in Braid chat, and they just reordered the statements, and it changed the performance for their Datomic query from 5.5 seconds to 38 milliseconds. Do you have any, personally, I don't have much experience with Datomic, but do you have any ideas as to why that might be the case?
If you're asking me, I'm looking at this and just off the top of my head, if I had to guess, I would say either thread, let's see, the one, is user ID the slow one? And my guess is you're hitting something that's indexed first on the fast one, and you're hitting something that's not indexed first on the slow one.
Oh, I just gave Raf the ability to talk.
Sure. Yeah, so on that end, the order of the statements in these queries is the order in which they, like, for example, load up these things into memory and then start filtering. And so in that case, by restricting, like initially when we had the users included first, it would pull in all the users and then all of their threads. And so effectively it would be putting like almost the entire state of the entire, every single user and every single conversation across every single group. So that's, imagine in Slack, if we want to find something, we almost loaded all of the Slack database in memory to run this query. But doing it in reverse, it'd be able to filter, or at least it would do it for a single user, like all the messages and conversations for that single user. And then the new version, by doing the thread first, it was able to limit and just find, given the thread ID, just the one thread, and then pull out all the related information. So basically, like, yeah, right, as I'm aware, effectively these databases right now don't have query planners that are like mature in any sort of way, and so they will just like naively do things in the order that you tell them. Whereas, you know, Postgres, for example, given this kind of situation, it would look at the size of these things and it might be able to infer a little bit about what it should do in what order. But currently, the Atomic data script family of things tends to be a lot more naive about their ordering. So you have to, it's up to you then.
And some discussion right now about which ones are open source, which ones aren't. I believe Crux is fully open source, and so are DataScript and DataHike.
Yeah, I think Datomic is the only one that is not.
Yeah.
And somebody said something earlier, had mentioned Clojure's Together funding to make improvements to some of those open source ones. I think some funding was just announced for DataScript, right?
Yeah, I believe so. And Crux is backed by Juxt, so they get funding through that.
Cool. Yeah, there are a few like feature non-parities between them, but they're very small. Like I believe I saw that. So if you're not familiar with return maps, and it's really just a minor inconvenience, but if you're returning a map, you know, like a name and a value, a name and a power, then you're going to return a whole bunch of pairs. And it would be really nice to actually, you know, sugar that up so that it returns the map of name pair, you know, about power to power. And Datomic added that, what, a year ago maybe? And it sounds like DataScript is going to get it soon. Yeah, there are minor differences in the syntax. Something else I've thought about, and this is just an idea I've had. I've never really haven't had the time. I've been too busy preparing to talk, but have an idea for like issue tracking. You know, if you know, we have, and I know there's really, you know, cool systems out there like, you know, Clubhouse, and you know, but I use Jira, and I do not have a wonderful relationship with Jira. But you know, some kind of a Datomic based or DataScript, you know, data log based system to actually allow you to link all your queries up that way to represent all of your issues as well as your tasking and your work, I think could be pretty awesome. I'm curious, is there anybody else out there that is currently using Integrant? If not, there's so James Reeves did give a really great talk. I can't remember the name of the talk, but I think the YouTube, the single slide shows like a little tree on it, but I think it's just called like Introducing Integrant or something, but it's very good. Cool. So Damon says they are using Integrant and migrating their production systems to it. Yeah, it wasn't until I think one of the failings of, not really a failing of Integrant, but a failing of teaching Integrant is, and maybe in a lot of these other systems, is the textbook examples are all like, hey, here's how you start a web server. Here's how you start a database. And, or maybe there's two pieces, or maybe but the two pieces may not have very many relationships. And so it really took me a long time to realize that, and I think a lot of people, when they hear it, they want to pass around the whole system map, and you don't realize until later that that's very bad. It's the components in that map that you pass around, and those relationships are what you build with that initial initialization function. And I just think there's not a tremendous number of I think tutorials and explanations about that.
It looks like, yeah, there's not any more questions going on. Raph did post something, about playing with more data scripts, data set stuff. Kind of neat. Yeah, so if I think that's all the questions for you, Mark.
All right. Thanks again, everybody. And with COVID and being at home and being having some work interruptions, I will still try to be around as much as I can all through the day tomorrow and stuff. And feel free to ping me anytime then, or you can always reach out on the Twitter or anything else. I'm always excited about Clojure. So
awesome.
Thanks, everybody.
That was a fantastic workshop. Take care, Mark.